So good evening. My name is Tammy Thornton. I'm the current president of Wilton Go Green. We have some other board members on here as well. Um, just a little bit about Wilton Go Green and some upcoming events before we get started and kick it over to Matt from Abode. So Wilton Go Green has been engaging, educating, inspiring green living since 2010. So this is our 15-year anniversary. So we have some exciting events coming up. So I want to share a little bit about those. Of course, if my mouse moves. Here we go. Really exciting coming up next month in March. We are doing an environmental film festival with 6 other local nonprofits in our area. This will be held at the Wilton High School Little Theater. It's 10 short films. We'll have food, drink, raffles, kind of a fun all-around fundraiser evening for all 6 organizations and a chance to kind of meet and greet with all of us. As it is our 15-year anniversary, we're also having an open board meeting next Wednesday, February 12th. An opportunity to learn how to get involved in our planning for this year's events and new programs, and also learn how to take on leadership roles. We, including myself, are stepping down from different executive positions of our board terms. So looking for some new and interested folks to kind of help take over and lead us into the next 15 years. Also in March, we're doing Green Drinks, which is another opportunity to come kind of meet with like-minded folks, learn a little bit more about Wilton Go Green. We're doing an evening Green Drinks at Marley's on March 6th and a daytime Green Drinks at Nova Cafe on March 14th. And then registration to come for a Composting 101 workshop with Jennifer Heaton-Jones, the Executive Director at HRA. So an opportunity to kind of learn about reducing food waste, but learn how to backyard compost, or if you're already backyard composting, get some tips and tricks for improving your current composting system. And then finally, in case any of you here are Wilton residents and you have high school seniors, we have for the last 4 years done an annual scholarship for Wilton High School Senior. There's an application that they are sent through their school links. So that will be coming out if not already. Just let them know to keep an eye on it if they would be interested. And as I mentioned before, we are looking as an all-volunteer organization for folks to step into either leadership roles or help us with one-day events or programs, help with a skill or join a committee. All of these are on our website at wiltongogreen.org/volunteer. The one and done events, the couple times a year events, and so on. And then if you are not following us on Facebook or Instagram, we're at Wilton Go Green. You can easily sign up for our newsletter on our website, and you can, of course, always email us at info@wiltongogreen.org. So just a little bit about us. I'm going to stop sharing my screen, and I'm going to let, where are you? There you are, Matt. I see you in my corner. So I'm going to let Matt Corona introduce himself and get started to learn a little bit about heat pumps. So we'll let Matt take his presentation. When he's done, we'll do Q&A, and if you need to put your question in the chat, in the meantime, you can, but we'll get to it at the end. And as you all have done and come in on mute and your video is off, that's great. But when we get to Q&A, you are more than welcome to unmute yourself and turn on your video if you'd like to ask your question or put it in the chat. So Matt, I'll let you take it away.
Hey everybody, thanks Tammy. So hey, my name is Matt. I'm a heat pump consultant with Energize Connecticut. So I live in Naugatuck, so I'm a Connecticut resident, and I have been basically my whole life. I went away for school and came back a few years ago. So happy to chat with you all tonight about heat pumps. I'm going to share my screen, and Tammy mentioned this, but I won't be stopping for questions during the presentation because I've just found that it ends up taking way longer than we normally hope for, and chances are I'll answer your question later in the presentation. But if you have questions, please put them in the chat, and we'll try to get to them by the end if they weren't already answered. And at the end, we'll have time for questions. So I'm happy to stay late if we need to. All right, I'm going to share my screen here. And everyone should be seeing this. So, okay, great. So, so tonight we'll talk about, we'll intro a little bit about Energize Connecticut, like what that is, and talk about heat pumps, all about heat pumps, like why someone want to consider a heat pump, different considerations there. and a bit about the resources that are available to help folks make the upgrade if they want. So, all about Energize CT. So, for those who don't know, Energize Connecticut is the basically the umbrella for the energy efficiency programs through Eversource and United Illuminating. So, the sponsors of Energize CT are listed here. It's mostly Eversource and UI and some of the natural gas utilities. And this is true of myself and pretty much everyone at Energize CT. Our goals are to help people make smart energy choices. So me personally, I don't make any money if anyone installs a heat pump or not. My goal is just to give people accurate information for them to make the right choice for them. So Energize CT ourselves don't sell or install anything. There are contractors that are enrolled in some of our programs, and they are like private for-profit companies, and we'll get into that a little bit later. But anyone from Energize CT like myself is funded by a very small, relatively small charge on your electric bill. So everyone is an Eversource or UI customer. You pay into the Energize Connecticut program, and so you have access to our educational services, our rebates, incentives, and other programs. So we'll get all into it, but that's what Energize Connecticut is. And now we'll talk about heat pumps. So what's a heat pump? A heat pump is basically an all-electric heating and cooling system. So in the summer, they work just like an AC air conditioner. It's actually the same technology. They're using refrigerant to move heat from one place to another. So just how your air conditioner moves heat from inside your house to outside your house, a heat pump does that same exact thing in the summer. And in the winter, they basically can flip in reverse and move heat into your home, even when it's very cold out. Like right now, it's pretty chilly. There's still a lot of thermal energy in the air outside, and heat pumps can basically absorb that energy and move it inside the same way that they cool in the summer. So it's pretty cool. Get two in one. You've got all heat pumps have an outdoor unit and one or multiple indoor units, and we'll look more at system design in a little bit. But they're even when it's 5 degrees outside or even colder, the refrigerant in the heat pump system boils at negative 50 degrees. So that's what's happening in the outdoor unit. It's forcing that refrigerant to go from liquid to gas by putting it under very high pressure. And so that when it boils at negative 50 degrees. So as long as it's, give or take, depends on the type of refrigerant. But as long as it's warmer than that outside, they can absorb heat from the air. And there are, considerations about cold climate performance. We'll get a little bit more into that in a little bit. But it is definitely possible to size and design a heat pump for all of the buildings, heating and cooling in our climate. We'll get into, there's some differences in like types of equipment, and we'll cover that in a second. So what we're looking at here are called air source heat pumps. So they are moving heat from the air outside, sourcing the heat from their air source kind of implies where that heat's moving from. There's also ground source heat pumps, which is really the same thing as geothermal. So if you've heard of geothermal, that's a ground source heat pump. It's the same, terms are the same. They mean the same thing. And basically these systems work the same way on the same principles, except that they take heat from the ground outside. So instead of an outdoor unit like you have for an air source heat pump, ground source heat pumps have a ground loop. And they can look at a few different ways. There's horizontal loop fields where they dig sort of like trench work in the yard. You need quite a bit of space for those. But there's also vertical wells that they take a drill rig and drill several hundred feet on the ground, and to get the amount of surface area you need to exchange heat. And these systems basically cost a lot more upfront. The installation of the ground loop is pretty expensive, but they're very efficient because the ground is a stable temperature all year round. So even when it's very, very cold outside, like right now, if you go down about 6 feet underground, it's a stable right around 50 degrees Fahrenheit underground. So the air source heat pump has to work harder when it gets colder because there's less heat in the air and they're moving heat from outside. Whereas the ground source heat pump has a stable reservoir of heat they're drawing from all year round, basically. And we're not going to talk too much about these types of systems tonight. So most of the rest of the content we'll go over is going to be specific to air source heat pumps. But just know this is another option for your home as well. So not all heat pumps, and again, we're looking at air source heat pumps here. Not all heat pumps are built for all climates. So there's systems that are built for our climate and even colder climates, and systems that are built for warmer climates that only don't get quite as cold temperatures, of course. So there's two things happen when it gets colder. So with heat pumps, so there's less heat in the air outside, so they have to work harder. So the efficiency goes down a little bit because they have to work faster, basically, to move as much heat into your home. So there's a bit of an efficiency loss when it gets colder, so they get more expensive per BTU to run. Also, what happens with some types of heat pumps is that they can lose some of their heating capacity as well. So two examples here, and these are not black and white categories necessarily, but so it's a spectrum. But standard heat pumps and cold climate heat pumps are generally how we define them. Both of these systems on the sticker can move 30,000 BTUs, and that's like an amount of heat. And just for comparison's sake, just an example. So when it's 47 degrees out, both systems can move 30,000 BTUs. But the standard heat pump, down when you get down to very cold temperatures, like here in Connecticut, we look at 5 degrees for performance because that's emblematic of most of the coldest temperatures we expect to see here. The standard heat pump loses more than half of its capacity, so it can only move 12,000 BTUs, whereas the cold climate heat pump can move all 30,000 it says it does down at 5 degrees. And so when it's cold is when your home needs all that heat, right? So if your goal is to do all of your home's heating in our climate with a heat pump, you definitely can, but it's important to select the right equipment, or really for your contractor to select the right equipment, and for you to communicate your goals with the system. And so what they'll do is they'll figure out how much heat your home needs at the design temperature for our region, and that's basically like where 99% of the heating hours are at or above the design temperature. So they figure out what does your home need at the design temperature, and make sure the equipment matches the performance of the equipment matches what your home needs. So there's a lot of, it used to be true that heat pumps didn't work quite as well in cold temperatures. So you might still see and hear people say, oh, they don't work well under 30 degrees, or they don't work well in our climate, whatever. Not really true anymore. But there is equipment that isn't built for our climate. So again, it's important to think through what your goals are with the equipment, whether it's full displacement or partial heating with a heat pump, and we'll get into a little bit more about those different options. But it's definitely possible to do it if you select the right equipment and it's sized and designed appropriately. So now we're getting into a little bit on design. So there's different types of heat pumps, different designs for heat pumps. All heat pumps, like I mentioned earlier, have an outdoor unit and one or multiple indoor units. So if a home has existing ductwork, then you can have a ducted heat pump and basically either swap out your furnace with a ducted heat pump air handler inside, or add a heat pump onto your furnace. There's some compatibility with that. It doesn't work for every system, but you can go dual fuel by adding a heat pump onto your furnace. So if you have a ducted system, relatively simple swap out. But if you don't have ductwork, a ductless system could make a lot of sense for your home. And so for ductless, there's multiple options for the indoor units. They come in a few different form factors. These are all inside or doing the exact same thing. And so they deliver the heating and cooling right into the room you're in, instead of blowing conditioned air through ductwork to your various rooms. The most common are these wall-mounted units, but there's also floor-mounted and ceiling cassettes, and there's even a few other more niche varieties of form factor, beyond these, but these are really the basic ones. And so if your home didn't have ductwork, you could install one outdoor unit with multiple of these placed strategically around the home to serve all of your need that way. So with ducted, there's also, if you have a centrally ducted home, you can most likely use that ductwork with a heat pump. But if you don't have ductwork existing, and say you've got like an unfinished attic or unfinished basement, rather than ducting the whole home, you can duct just parts of the home. And so compact ducted units are, they're not built to serve the entire home, but they work really well where you've got smaller, more compact rooms that are adjacent to one another. For example, in a lot of colonial style homes, you have 3 or 4 bedrooms upstairs and a bathroom. You can use a compact ducted system just for the upstairs to serve those few rooms up there rather than ducting the whole home. If you were to extend the ductwork like from the basement up to the second floor, that's a really expensive and invasive project. You might have to open up walls, things like that. So if you don't have existing ductwork but you have unfinished space, you can use that to do some ductwork in the home instead of doing the whole home. So there's a lot of versatility with these systems. You can have, and I should say, the ductless units can go anywhere in a home, but they work particularly well where you've got larger, more open spaces. So, just using that colonial home as an example, you might have like an open floor plan downstairs with like your kitchen, living room, dining room space. Sometimes, depending on the size of the space and how well the air circulates, if it's if there's walls or things blocking the airflow between the rooms, you could maybe do like 1 or 2 ductless units downstairs and serve the whole downstairs area that way. So these really shine best where you've got, again, larger, more open spaces, and ductwork is best for smaller, more compact rooms where you could serve multiple small rooms with one ducted unit instead of having a ductless head in each bedroom, for example. And single zone systems are really the most simple. They're 1-to-1, so you've got one outdoor unit with one indoor unit. Those usually really work well for like addressing a comfort issue if you have in a certain space of the home, like a sunroom, for example, where you have a lot of heat loss from the windows, or like a basement. Maybe if you're finishing a basement and you didn't have heating there before, you can do a single zone system that way. Multi-zone can be a combination of both ducted and ductless. So you can do one outdoor unit with ducted in the attic and 1 or 2 ductless units downstairs. So a lot of versatility with these systems, and they can really be designed specific for a home. My goal here is to give you an idea of what's possible. And if you were interested in installing a heat pump, a contractor would come to your home, figure out what size of system you need, where things need to go, if you can do ducted or not. So don't worry about designing your own system. But my goal is to like help you guys get some good ideas to ask contractors and an understanding of what's possible with these slides here. So again, lots of versatility, and with this, with using a branch box, you can have even more indoor units. So you can really get complex with these systems, but also very simple if you do like single zone. So that's all we've got on design. So now we'll talk about benefits and considerations here. So why would you want to install heat pumps? So number one, you can heat and cool with one system. So, rather than having a furnace and an air conditioner and they're separate and have different lifespans, like you can, combine those systems into one and replace, 2 systems, kill 2 birds with 1 stone. If you needed to replace both your furnace and your AC, you can just do a heat pump, and likely that would be less expensive than having to do both of those pieces of equipment. So advantage there. In a lot of cases, and we'll look more detail at this in a couple slides, is lower heating and cooling costs. So compared to oil, propane, and electric resistance heating, heat pumps in an average year cost less to run than oil, propane, or electric resistance. Gas is a different story. We'll talk about that. And lower carbon emissions by pretty much compared to any other heating system. We'll look at that too. We've got some data we can look at. Okay, So this is this graph's a little bit complicated. It is basically comparing the costs of creating or moving 1 million BTUs with different heating types. So we picked 1 million BTUs because it's like a standard amount of heat. And so if you were to have to provide that much heating with different heating systems, what would it cost you? And this is using about 10 years of historical weather data and 3 years of energy cost data. So we look at averages because if you look at the cost at any given time, like a spot price of oil versus electric, for example, it's going to be quite different. And right now, to be fair, electric costs are relatively high. So, on an average, it's pretty good today. So we can get more. People have questions. We can get more into the weeds about today's costs. But when you look at averages, so what we've got going on here, there's the first thing to look at here is this kind of shape in the back. I want to point out that is the average number of heating hours that we get in our season at these temperatures here along the bottom. And this is for Hartford weather data. So down in Wilton, it's going to be a little bit warmer on average. So it's like a bell curve you can see, and you might just shift that over a couple of degrees down, being down near the coast versus Hartford. So, but similar looking graph it should be. So that's using the scale here on the left, average number of heating hours. So you can see we get a lot of hours between 30 and 60 degrees, where it's still need heating, but it's relatively warm compared to our coldest times of the year, of course. And so, like we looked at earlier, okay, so the scale here on the right is the cost to create that million BTUs. And so these lines across are showing us how expensive it is to create that million BTUs with different heating systems. So propane is about $45 to create that million to create 1 million BTUs. Oil is about $36. And those lines are straight across because it doesn't matter how cold it is outside. When you're burning oil or burning propane, it has the same amount of heat in it. So your home needs more heating when you get colder, but the cost to create that same amount of heat is the same. Versus heat pumps, which actually do get less efficient when it gets colder, again, because there's less heat in the air outside and they're moving heat from outside. Their lines increase as it gets colder. So that cost to move that same million BTUs goes up. And with, based on the last 3 years of average energy costs, there is a point where it's actually cheaper to use oil compared to air source heat pumps. And these are 3 example systems we have on here that vary. They're all cold climate heat pumps, but they vary a little bit in their performance. So one thing one of the takeaways here is that the performance of the equipment, especially if you're switching from oil, matters quite a bit when you're determining are you going to save, how much you're going to save from oil. Propane, if you have propane, pretty much always makes more sense to run the heat pump versus propane. If you have electric resistance, like electric baseboard heating, very, very expensive to run. If you have that, I'm sure you know. But yeah, heat pumps, you could stand to benefit quite a bit from switching to a heat pump if you have electric resistance. Propane and oil, like less so, but there's still potential savings there. Gas is another story. So you have natural gas. It's heating's cheap, heating expensive no matter which way you slice it, but relatively inexpensive compared to those other fuels we were talking about, and pretty much are going to be cheaper than air source heat pumps 90% of the year. Ground source heat pumps, geothermal, is similar to natural gas costs and cheaper than air source heat pumps. So you can kind of see here, it's hard to justify the cost of going to a heat pump if you have gas. But some people, everyone has different, weights the benefits in different ways. So if the carbon emission savings are really important to you, it might still be worth it for you. But if you're looking purely on a financial perspective, it's a little bit harder to justify. And then, down here on the bottom right, I hope folks can see this pretty well, but I've just got for an average size Connecticut home, what the approximate annual cost would be for those different systems. And you can see the 3 heat pumps fall between gas and oil here. So all 3 of them show savings compared to oil, but between 5 and 30%. So again, this is using average costs. If you look today, oil's high, but electric costs are also very high for a number of reasons. But yeah, so today's spot price, would be close, relatively similar to oil. I think this air source heat pump one might cost a little bit more than oil, but the other ones would probably still show savings. This is a really similar chart, but looking at CO2, pounds of CO2 emissions instead of cost. So the biggest difference here, these lines look very similar, right? The air source heat pump lines, but the biggest difference is that oil is way more carbon intensive than electric resistance, or I'm sorry, than air source heat pumps. So whereas oil was like pretty close in terms of cost to air source heat pumps, the carbon emissions are quite a bit higher. They could be like almost 3 times as much, depending on the system you have and the efficiency there. Gas is also, whereas like one of the cheapest fuels, it's still a lot more carbon intensive than heat pumps. So even when you account for the energy generated on the grid, which is in New England is mostly gas, mostly natural gas, because of how efficient the heat pump is at your home, even when combined with the efficiency of the generators, it's still far and away better in terms of carbon emissions than those other fuel types. All right. Okay, so some other points here. We always recommend folks, before thinking about a heat pump, take a look at how efficient their home is. So do you have adequate insulation? Has the home been air sealed? Those are things that you can have addressed through the Home Energy Solutions program. If anyone, we'll have another slide on this, but it's basically like a subsidized energy assessment through Energize CT. So you can have a professional come to your home and figure out, would you benefit from insulation? If so, they can offer you rebates for the work that they recommend. So totally a valuable service. We'll talk a little bit more about that in a few minutes, but highly recommend that before installing any new heating system. Goals and motivation. So always just recommend thinking through, again, your goals can be different with a heat pump versus someone else, right? So like you could be in need to replace your whole heating system, or you just have a comfort issue you want to address in part of the home. Just thinking through like, what are your main motivations, communicating your goals clearly to a contractor so that they can install equipment that will meet your expectations and meet your goals. So whether it's comfort, improvement, or savings, or reducing your carbon footprint, you can accomplish all these with a heat pump, but you might make different decisions if one or more of these are more important than another to you. So I mentioned the ability to keep your existing heating system with a heat pump. So you definitely can. So how you would do that is you would, for example, if you have the furnace, you can add a heat pump on top of the furnace, or if you have baseboard heating or radiators, hydronic heating, you do ductless, you can basically integrate those it's like a fancy thermostat called integrated control. And it basically connects to both the heat pump and the legacy heating equipment. And you could have it set up in a couple different ways, but normally you could have it set to switch over from the heat pump to oil at 20 degrees or 30 degrees, whatever outdoor temperature you want. Or you can have it set to just use your other heating system purely as a backup on like the very coldest of nights, or if something went wrong with the heat pump. So yeah, if you have a perfectly working heating system and it's not, very, very expensive to run, could make sense to keep it and integrate it with the heat pump if that's part of your goal. All right, so we'll look at just quickly kind of breeze through these as just an example, 1,500 square foot floor plan. And so, this is not to scale. Like this unit is a lot bigger than it would actually. It wouldn't be bigger than your dining room table. But this might be, you got one ductless head here in the home, and this probably wouldn't be enough to completely do all the heating for the space. This might, if you had a comfort issue or a drafty living room or dining area, this would be really great to address that comfort issue. Or if you're like looking mainly for cooling, you don't have existing AC, this would be a good way to keep your main like living space comfortable. But you've got like a pretty long hallway down here and 2 bedrooms, and the doors might be closed. So this one ductless head is not going to do a great job of keeping those bedrooms comfortable. On the other extreme, this is this might be the only way to do it, but generally we try to recommend folks don't put a duct or a ductless unit in every bedroom, because oftentimes the bedroom doesn't the units only go down to a certain size, and a lot of times really small bedrooms will be the equipment will be oversized for those bedrooms, and so that leads to sometimes performance or comfort issues if equipment's oversized. So if you have the ability to use an unfinished attic or basement space to serve those smaller rooms, again, highly recommend that. So this is like a good compromise between those two extremes, where you might use ductless for, again, this like more open space here. And if you notice, like this one's positioned in such a way that it could like blow air over here, blow air over here to keep the whole space comfortable. And then this is a compact ducted unit. This is like what they actually look like. So it's it's hard to tell if you didn't know what they look like, but then you can have vents into each of those rooms and serve those bedrooms that way. You could even add a duct over to the bathroom as well and serve the bathroom. So yeah, if you can simplify the system by serving multiple small rooms with a ducted system, highly recommend that. Like, this is something that contractors should look for as well when they're giving you a quote. So yeah, it eliminates that like oversizing for the bedrooms. Some owner maintenance tips: clean the air filters. So if you have a ducted system or ductless, the ductless heads have like a vent flap that comes up, and they have a filter that you just want to clean off every. They usually say every 3 months, but it really, some homes won't need it every 3 months. Some homes will need it every 1 month. If you have like I've got cats, I probably got a bunch of cat dander in the home, that might increase the need to clean the filters. If you have a ducted system, you should already be doing this, but there's a filter in the air handler in your basement or wherever the furnace is, and that filter needs to be changed at a similar frequency. The outdoor unit, just don't want to let big leaf piles accumulate near it. It's got to have good airflow to get the heat exchange with the outside air. So just don't want to let branches accumulate by it. Or in our climate, they should be installed. Outdoor cold climate heat pumps should be installed on a stand. So most of the time you don't have to worry about ice and snow, especially down in Wilton. You're on average you're gonna get less snow than like Litchfield County, for example. And then have this equipment serviced annually. Highly recommend that for any heating and cooling equipment, but heat pumps also need to be serviced. When you install the equipment, they should offer you a service contract. All right, so we'll get into some resources now. So I mentioned the Home Energy Solutions program before. It's a $75 copay, and you get a whole analysis of the home's energy performance, and you can come away with some recommendations for installation, and they'll offer you rebates for what they recommend. So they're only recommending things that would make a significant improvement in the home. The investment has to pay for itself over time in energy savings. So the way that they're making recommendations, you're going to get, not going to get recommendation for something that's not actually going to make a difference. It's all going to be worthwhile upgrades, and you get some help doing it from the rebates that can pay, I think, up to 75% of the upgrades. So pretty significant help to make the installation upgrades that you might want to do before installing it. So there's also rebates through Energize Connecticut for heat pumps. And if I'm not mistaken, Wilton is all Eversource territory, right?
Yes.
Okay, great. Thank you. So for Eversource customers, you can get $500 per ton for the heat pump equipment. So that's, the tonnage is like the size of the equipment. The capacity is a measure of the capacity. So really it's based on how, if you go with a single zone unit, it's going to be smaller. Obviously, if you do your whole home, it would be dependent on what your home needs and the equipment that you end up installing. We do have a qualified products list, so there is efficiency criteria for the equipment. It's got to perform pretty well in cold climates at least. Ground source heat pumps can get $1,500 per ton. So like I mentioned earlier, they're more expensive up front, but lower operational cost. And then this is new in 2025, but if you have an existing heat pump, or if you don't have pre-existing heating, because one of the requirements is that your displacing existing heating. Then you can get 250 per ton, which is less, but is nice for like if you had an existing heat pump, technically you wouldn't be able to get anything before. And then there's also a federal tax credit. This is current as of today. But yeah, there's a 30% tax credit off of your federal taxes, up to $2,000 for air source heat pumps. So usually for a whole home project, you're going to hit the $2,000 cap. So for most whole home projects, it's basically $2,000 in tax credits. For ground, so this is for air source heat pumps. For ground source heat pumps, it's 30% with no cap. So again, the equipment cost or the install cost is a lot more for ground source, but the tax credits are way bigger and the rebates are larger from Energize CT as well. And there's also there is efficiency criteria for this as well. So on the Energy Star website, you can find there's a find eligible products tool, so you can search by the different equipment types. So pretty much we've been talking about heat pumps that are doing your space heating. So your cooling and heating for the air in your building. They're also heat pump water heaters. So these are separate systems that are package units. So people say splits for heat pumps. They mean the outdoor unit and the indoor unit. That's the split. They're split up. These are package systems. So the heat pump is right on the top of this unit. This is a heat pump. So, if this was in your basement or your garage, they are using that air in that space to heat the hot water. So they actually cool down the air a little bit in your basement, almost negligible. You probably wouldn't notice. And they also dehumidify the air by cooling it. They're extracting moisture from the air. They're a lot more efficient than pretty much any type of water heating except for gas. Gas is around the same cost as a heat pump water heater to operate. And we've got a $650 rebate from Energize CT. There's also that same tax credit, 30% up to $2,000 for heat pump water heaters as well. So there's both the tax credit and rebates for these. We have a list of qualified contractors who can use those rebates on the Energize CT website. We make sure that they're insured, licensed, and trained, so they're all legitimate businesses, but definitely recommend cross-referencing our list with other research online, reading positive reviews. You can go to heat pump manufacturers' websites, and they've got like their recommended installers, so I recommend just cross-referencing those things. And we do heat pump consultations. So my team, and I do these, and one of my colleagues, Luke, does them as well. We have no cost consultations all through Energize CT. This is a QR code actually, so you can scan this if you want on your phone and sign up. If you're considering a heat pump, we can walk you through like what might make sense in your home based on the design, answer any questions you have about performance, or we also do quote comparisons. So when you do get quotes, we have software that we use that can compare the performance between different equipment, and we like model them across the whole season. So really the goal is just to help you make a smart choice. Again, we don't make money if you install a heat pump or not. Our goal is just to help people feel comfortable with the decisions they're going to make. So highly recommend this if you're thinking about a heat pump and you're feeling lost on where to start, or you got multiple quotes and you're not sure how to tell the differences. We can help you there. And just to highlight some other resources we've got on the Energize CT website. So if you go to energizect.com/cleanheatcool, it's got all these resources listed on the bottom. So we've got guides for all the different types of equipment, user tips, that consultation service I just mentioned. We've got a quality installation checklist, so you can like walk through after and make sure they did some of the basic stuff right. Questions for your installer guide. I highly recommend checking that out if you're planning to get quotes. It can give you some good questions to think about. Our Find a Contractor tool, and here's a link to some other good resources as well. And that's it. So I'll stop sharing, and then happy to answer any questions.
So if folks want to just raise their hand, I could call on you. I did put some links in the chat for folks to get to the heat pump qualified product list, the energy solutions, the home energy audits in there. And then I don't know if you can put the website from the QR code into the chat because I did click on it and it says the site cannot be reached. So I don't know if it's just me or something else. So I'm not sure if anyone else tried. Um, but if you wouldn't mind just putting what that website's supposed to go to into the chat. Oh, Matt, you're on
Yeah, I
mute.
can do
There
that
you
right now. Here's the it's at page@energizect.com. So I just put the link in the chat, and it should say like schedule a consultation on there, and you can click that. Oh yeah, sorry about the QR code.
go. Oh yeah. Okay. Yeah. Mine was trying to go to letstalkheatpumps.com, but it didn't show up. That's what it says. I don't know if that's where it's supposed to go. Okay,
Oh,
great. Um, so do you know what a typical ground source heat pump would cost for a 5,000 square foot home? Very hypothetical, but ballpark?
uh, so
That was a question in the chat.
it's a quite a large home. So I would say, um, we see a lot of variance in general for all costs for heat pumps. So always recommend when you get quotes to get at least 3 quotes. We recommend 3 to 5, because even for some of the same equipment, a lot of variance. So you might have some contractor bidding on it and be way more than another. I would say I would say it would be north of like $50,000. Probably. I mean, it might even be like 70 or 80,000 after all the tax credits and stuff. It's a ground source heat pumps are very expensive. I would say most whole home air source systems will probably cost between like 15 to 25,000. Ground source is going to be like usually more than double that. So um,
To take the time to get the quotes and ask and get people to come to give you a really better sense, for sure. Someone asked, what's a branch box?
a branch box is a device that can basically there's the outdoor unit and there's a refrigerant line going from the outdoor unit to the indoor units. The branch box basically like allows the system to split that refrigerant line up into multiple lines. And so there's systems that are usually residential size systems are limited to 4 or 5 ductless indoor units. But with a branch box, you can do usually up to like 8 or so. So it depends. Not all manufacturers, offer a branch box option for their equipment. But like, say you had a home with no attic space or no basement space, and you had like a ton of small rooms, like 4 bedrooms, and your closed floor plan on the first floor, you can do more than the typical 4 or 5 indoor units by adding a branch box. So it basically like um, it's a little bit more complicated than this, but they like split up the refrigerant line essentially. Um, there's some cooler engineering videos if you look up how does a branch box works. There's if you're interested, there's some cool content there.
And then Katerina wrote, is it possible to do a retrofit heat pump in an existing older home? They have baseboard heat, which is oil and hot water, and then electric based air conditioning.
Yeah, absolutely. So Katerina, if your air conditioning system uses ductwork right now, you can basically replace the outdoor condenser and the air handler, which probably lives in your attic, with heat pump versions of those, and use that existing ductwork to do heating and cooling for the home that way. And mechanically, they're the heat pump, and because they're using the ductwork and your baseboard, mechanically it wouldn't be interacting with one another. So there's no reason you have to get rid of your baseboard heating unless it's like at end of life and you need to get rid of it. So you could do like a dual fuel system that way, where you have the heating and cooling done through ductwork with the heat pump, and then keep your baseboard as like a backup. Or if it's oil, like we looked at, it would save you money a little bit to switch from the heat pump to the oil at say like 20 degrees or 30 degrees, because oil is a little bit cheaper at those really cold temperatures.
Great. I don't know if anyone else has a question, or do the wall units and ceiling cassettes work similarly?
Yeah, inside they're exactly the same. So they really there's a coil inside and a fan that blows air from the room over the coil, and they're doing the exact same thing. They just look different. So if you prefer one of the look, a lot of people A lot of people don't like the look of the wall units. That's totally fine. Ceiling cassettes are a little bit less obtrusive. And so, yeah, if you prefer the look of those, there's really no difference in the performance or anything like that. Um, One thing I will say though is that not all homes will be able to do the ceiling cassettes. Older homes, newer homes have at least 16-inch floor joists between the floor joists. So like if you're on the first floor, there's the joists are like the beams that support the floor above it. And they do need a certain amount of space between them to fit those ceiling cassettes in. So not every home will be able to do those, but many will.
All right, good thought. Anyone else have any additional questions? You can raise your hand, you could ask yourself, you could put it in the chat. Give it another. I don't know if anyone has. Oh, wait. Oh. Drafts and breezes are a problem. How far do they shoot out of the units? Oh, so like how far does the air extend? Good question.
Yeah, great question. So when so all manufacturers in their like performance data for the equipment have a rating for how far they can throw air. So that's like what you're talking about is how far does like the blast of air come out of it. Some of it's dependent on the fans in the ductless systems have multiple speeds. So depending on like how much heat you need in that exact moment or how much cooling you need in that exact moment, they might be like a lower fan speed than if you need a lot, like so if it's not super hot out and you just need a little bit of cooling, they're going to run a really low fan speed and be like almost silent and not throw air very far. Versus if it was like 105 or something and it was really hot and you needed a lot of cooling, or vice versa, need a lot of heating when it's very cold out. They will like blow air a little bit farther, but that's definitely a consideration for the installer to think about. Like, for example, you might not want to put one pointed at your couch, your living room couch that you sit on, because that draft will affect your comfort level as well. So, but they do have like louvering fins on them that can blow air and point them in different directions. So they try to do that to like mix air up in the room, but still, like if it's generally pointed in one direction, most of the time the air is going to be blowing at that. So, yeah, the placement is definitely important. An important consideration for the throwing of the air.
So another person wrote they have a whole house generator, so can heat pumps be hooked up to the whole house generator?
Absolutely, yeah. So I guess if there's one like con, I guess you could say, about a heat pump is that they use a lot of electricity, right? So if you can run a boiler or a furnace with a portable generator because they don't use that much electricity. It's really just like the sensors, the fans, like the thermostat, and they most of the energy is coming from the propane or the oil or whatever, net gas. Versus a heat pump, it's all electricity, right? So a portable generator typically are not going to be able to provide enough energy to run a heat pump in the case of a power outage. The other thing is that the energy coming out of a portable generator is not like as steady of a flow as whole home generators. So having a whole home generator puts you an advantage with a heat pump because you can definitely power that. Assuming you're sized for it, you can power that heat pump in the case of a power outage. But I would say like it really depends on your risk tolerance and like how many power outages you get. Like I don't know if Wilton's like prone to that, but where I am, like we rarely ever get power outages. And if they do happen, it's like a couple hours at most. So I personally wouldn't be worried about having a whole home generator, but if you do, that definitely is a nice thing to have with the heat pump. Um,
Okay, I'm going to try and put these two comments together. So, Gavin asked, when do you expect serious air to water heat pumps to be available, like in Europe, where the air to water heat pumps used in Europe that make the domestic hot water? Are you reading this, Matt? Okay.
yeah. So so there are, we talked about heat pump water heaters, which are heating hot, like your domestic hot water, but you're talking about air to water heat pumps. So everything we said about air source heat pumps tonight was pretty exclusive to air heat pumps. So they're moving heat from the air outside to the air inside. There are in Europe way more popular in Europe, air to water heat pumps. So they're taking heat from the air outside and moving it into water that's distributed throughout the home, like with like for example, like baseboards, right? So
Yeah.
and that the heat ends, goes from the baseboards to your air, right? But the thing is, in Europe, they have different style radiators where there's a lot larger surface area relative to the amount of water passing through. So they don't need the water quite as hot to deliver heat through those types of European style radiators. Here in America, like the American style baseboards, most of the time are designed designed for water temperatures like around 130 to 150 degrees. Um, heat pump water, or I'm sorry, air to water heat pumps that we have today with current technology max out at around 110, 120. So they work really well if you have in floor or in ceiling radiant heating, because they're designed for water temperatures much lower, usually like 80 to 90 degrees, versus the baseboard. So it really depends on the type of hydronic heating you have, whether it be compatible. But the technology is like not really compatible with most style radiators here in the United States, unfortunately, at this point. But what you said about Gavin, what you said about the propane refrigerants, so that is like slowly happening. So I think you're talking about R290 refrigerant. That is like, there are some systems that are getting released with those refrigerants now, and there's also another big refrigerant change happening, mostly to address global warming potential of refrigerants. But yeah, I would say probably in the next 5 or 10 years. I don't think it'll happen very soon, but I'm sure we'll get there.
Okay. Yes, a comment. Yes, electricity is high in Connecticut right now. So the comment about benefit is a lower carbon footprint, but not much cost of benefit due to the expense of electricity. Um, was a comment. I don't know if you want to respond to that.
Yeah, I mean, we looked at the that graph a little bit earlier. So I would say in general, you could definitely expect to see savings, even with current electric costs. Comparing between, if you're looking at switching from propane, you'll definitely save some money. Or electric resistance heat, so electric baseboard, you'll definitely save some money switching to heat pumps. Oil right now usually shakes out to almost the exact same cost as air source heat pumps. Even with I know electric is expensive, like one of the most expensive states in the country. But yeah, I mean, oil you should expect to come out about even with the current costs. And gas, you're not going to see savings, to be frank. Even if costs go down a bit, gas is just relatively inexpensive. So yeah, I would say, Christina, in general, you're right. I think it really depends on what fuel you're switching from. One thing I'll say too is that the public benefit charge should be going down about 3/4 of it coming up in the next couple of months. So if you can Google this if you want to learn more, but there's like a power agreement with Millstone, the nuclear power plant, that really drove up the public benefit charge, but it was only 10 months the agreement lasted. So I think at the end of March, if I'm not mistaken, that should come off, and energy prices will still be relatively high compared to other states, but should go down 3 or 4 cents a kilowatt overall. I think so. Um, you know,
Great.
that's what I look forward to.
Yeah, thank you. And then just the last question was, is it recommended to upgrade to 200 amp service for 5 or 6 units? So upgrading your electrical box, I'm assuming.
Yeah, you might need a panel upgrade to do a heat pump. Most homes will, again, because they're just using a lot more electricity. So that is something to factor into the upfront cost. There are people who do it on a 100 amp panel. And, if you want to, I would say in any case, when a contractor recommends a service upgrade, asking for the electrical load calculation is important, because a lot of times we'll just say, oh, yeah, you probably need it. Of course, we'll sell it to you. But and most of the time they're right, and you probably do, because again, heat pumps use a lot more energy. But that's something just to check on that recommendation, would be to ask for that electrical load calculation, which will tell them like, oh, based on you have your fridge and so many lights and whatever else, and the total draw would be over 100 panel or 100 amps with the heat pump. So that's what I would want to see personally.
Well, Matt, I thank you so much for taking the time to do this with us. I thank everyone for coming tonight, asking great questions, and for being curious. And so I will send out this recording to folks in a couple days, and then also put the contact information that Matt had shared as well for people who might be interested in learning more about different heat pumps. So thank you so much.
Of course, happy to be with you guys. Thanks for having me.
Thank you so much.